Hi, this is Mr. Anderson. Today I'm going to talk about chemical bonds. Chemical bonds are attractions between either atoms or molecules. Now a little bit later we'll talk about intermolecular bonds, so those are things that are attaching molecules together, but right now we're just talking about straight up chemical bonds, in other words attractions between atoms. I've pictured four of them on this diagram right here. Our four different types are covalent bonds. So covalent bonds are going to be broken into two different types. These ones right here would be polar, so I'm talking about the water itself, or the H2O. And then over here, this would be a non-polar covalent. Non-polar covalent, this is some diesel fuel that's been spilled. It's actually C16H34. And so in a covalent bond, what you're doing is you're actually sharing electrons. You're not stealing electrons, but you're sharing them. And it goes from sharing them very equally in a nonpolar bond to sharing them very unequally in a polar bond. So these are the covalent bonds. Next one we'll talk about are going to be ionic bonds. Ionic bonds, in ionic bonds, you're actually transferring electrons between two different atoms, and those become what are called ions. And those ions are what are attracting it together. And so in this case, we've got NaCl, or just regular table salt, and that's an ionic bond. Now the other bond that's pictured here that I won't talk about today are going to be metallic bonds. Metallic bonds are found within metals. And they don't share their electrons. They kind of collectively share their electrons, so it gives them cool stuff like hardness and conductivity. And so we're not going to talk about metallic bonds. But today I'm going to talk about covalent bonds, both nonpolar and polar, and then ionic bonds. And mostly what I want to talk about today is how do you figure out what kind of a bond it is? If you're just given the atoms, how do you know? Okay, so I want to digress a little bit and talk about the octet rule in kind of a roundabout way. When I was a kid, the most important toy you could have was Star Wars action figures. Now I'm dating myself a little bit. In other words, if you went over to a kid's house and they had all these action figures, it was going to be a great day because you knew they had them all. And so what were the big ones? At least on the good side, the big ones, you had to have a Chewbacca, you had to have a Han Solo, Princess Leia, you had to have Luke Skywalker, you got to have your C-3PO, Obi-Wan Kenobi, maybe you had the Yoda, and then you had the R2-D2. Now if you had all 8 of those, you had a complete set. I remember flushing my R2-D2 down the toilet just inadvertently, and it was like one of the most sad days of my whole life. And so if you had, let's say, 7 of the big 8 action figures, you really wanted that last to collect your to complete your set. And so atoms are the same way, and they have what's called the octet rule. And so what does that mean? If you're oxygen has 6 electrons. It would love to have 8, so it's got 1, 2, 3, 4, 5, 6. It would love to have 8, and so it can share those electrons with carbon, and so it can have a complete set. In other words, the secret of life, or secret of chemistry, at least half of chemistry, is that atoms are always searching out a complete outer level. In other words, they want 8 electrons in the outside level. Now likewise, carbon, since it's got 4, it's got 1, 2, 3, 4, it can share those with the other oxygen. And so in carbon dioxide, they both have 8, or all 3 of them have 8, and so they're all happy. In other words, it's like having a complete set of action figures, and you're good to go. Okay, so how do you know which type of a bond it is? Well, this will vary a little bit depending on where you get your stats, but these numbers are pretty important to remember. If you have somewhere between an electronegativity difference of 0.5 and 0, it's a nonpolar covalent. If your electronegativity differences are between 1.7 and 0.5, then it's a polar covalent, and it's above 1.7, then it's ionic. Now, first thing I need to talk about then is electronegativity. What is electronegativity? Electronegativity is a measure of how much you want electrons. And so the more electrons you want, or the more you need those electrons, the higher your electronegativity is. And so fluorine up here, fluorine has 7 valence electrons. That means if it can get 1 more valence electron, it's going to have a complete set. In other words, it almost has all the Star Wars action figures except maybe Yoda. If it can get that last one, then it's going to be happy. And so the highest electronegativity of everything up here is going to be fluorine. It has an electronegativity of 3.98. And so as we move across the periodic table, those numbers get larger. Also, as we go up on the periodic table, they increase as well. So who doesn't want any electrons? Well, it's francium. Francium has a electronegativity of 0.7. That means it has one valence electron. It doesn't need to hold on to it that much. In other words, it'd be easy to give off that electron. It has a complete set right underneath it, and so it's going to be really, really happy. And so by looking at the differences between the atoms and their electronegativity differences, we can easily figure out what kind of a chemical bond we have. So let's do some. For example, let's do water. And so you know that water is H2O. So all we do is look up the electronegativity of the two atoms. And so here's our hydrogen right here. Here's our oxygen. Well, oxygen's electronegativity, I'm just reading it on this chart. So in my class, you'd have to use your periodic table. It has an electronegativity of 3.44. I'm going to subtract that of hydrogen, which is 2.20. And so I get a difference of 1.24. That's the difference in their electronegativity between these two. So what kind of a bond is that? Well, look at my chart. It's somewhere between 0.5 and 1.7, and so I know immediately that that's going to be a polar covalent bond in water. Let's go to another one. Here's diesel fuel. This is centane. Diesel fuel is going to be C16H34. So if I look at, it's hard to draw there, the bond between a carbon and a hydrogen, I just find them on the periodic table. So carbon has an electronegativity of 2.55. In other words, it wants the electrons a little less than oxygen just did. Hydrogen has an electronegativity of 2.20. And so if I find the difference between those two, I get 0.35. And so what type of a bond is found in diesel fuel? Well, it's less than 0.5. And so that's going to be a non-polar covalent. That also explains why when you have diesel fuel and you pour it into water, they don't mix, because one of them is non-polar and the other one is polar. And only likes will attract to likes. Okay, let's go to the last one. That's salt. Salt, what is salt? Salt is NaCl. If we look up our electronegativities, salt, we're going to find sodium, all the way over here, so it's 0.93. I'm going to then find chlorine. Chlorine is 3.16. 3.16. So I subtract 3.16 minus 0.93 as I try to do that in my head. That'd be like 2.3. So it doesn't matter if I got my math right. We know that that is greater than 0.17, and so we know that that's going to be an ionic bond. And so when you look at salt, these are actually chlorine ions that are attracted to sodium cations. In other words, you've actually transferred that electron from the sodium to the chlorine, and so those like charges are attracting it. If we were to do one more, this is ammonia, and so ammonia is NH3. And so you should be able to figure this one out. So first we look up hydrogen, then we look up nitrogen, and so the difference is going to be 3.04 minus 2.20. And so which one is it? Is it nonpolar? Is it polar covalent? Or is it ionic?